Hey everybody, let's give this problem a try. So we're trying to decide between the node voltage method and the mesh current method. And you can use either, they both work. But let's keep an eye out for things like supernodes or super meshes. So say we started to look at the mesh current method. We have 1, 2, 3, 4 meshes over here. I'll just label them with some mesh currents. Okay, and notice that this mesh up here and this mesh up here have this current source in between them. So this is a super mesh right here. Okay, so then you could write 3 equations, right? You can write KVL for this mesh, and then the super mesh. So let's say we did that. So for this mesh over here, let's go around clockwise. I'll start right here. So KVL, so 100 IA, and then over here, minus 20, and then over here, 250 IA minus IB. Okay, now let's go KVL over here. I'll just start here. So going clockwise, 200 IC, now we're over here, plus 500 IC minus IB, now over here, the voltage minus 0.4 VA. Okay, and then VA is right here. And already, like, how do we define VA? For this picture, just look at this resistor. So VA is 250 IA minus IB. So then you could substitute that there. Okay, and then for the super mesh, let's see. Already, I see an issue. So we're trying to write KVL. What's the voltage from here to here? We know the current is this, but the voltage is yet unknown. So we actually have to define some voltage. Let's see, I'll just call it V1. So some unknown voltage. So if we go clockwise, KVL, V1, that's already, we introduced this extra unknown. Plus, now we're going this way, 0.4 VA, and then again, VA is this. That goes there. And then going this way, plus 500 IB minus IC, and then going up this way, plus 250 IB minus IA, and then now going this way, plus 20. Okay. So already it's a bit of a mess, right? And then we have to write constraints. For example, I already wrote this one here. And then we also know the current, you see this current right here? It's aligned with our mesh current, ID. So actually mesh current ID is this, 0.003 V delta. And then V delta, what is that? V delta, take a look, it's right here. Let me erase a little bit. Okay, V delta is right here for this resistor. So it is 500 IC, IB minus IC. Okay, and then this mesh current and this mesh current, right, have this in common. And notice the way the arrow is going, right? So mesh current ID is going this way. Mesh current IB is going this way to the right. So which one is more? ID is more, right? So ID minus IB is 200 milliamps. Okay, so this is what we have to solve, which we can get the 4 mesh currents. Once you know all the mesh currents, then you can solve for everything else, right? You get the voltage everywhere, and you can get the power. If we wanted the power for the source, that would be right here. So if you want the current here for the source, that would be mesh current ID minus mesh current IA. Right? So you solve for that times 20 volts would be the power. Okay, let me borrow this picture here. So already it looks like a huge mess to use the mesh current method. Is the node voltage method any better? Let's take a look. Okay, there's a lot in common here, so I'm going to put a reference here, and I'll just label, I see this is called VA, so I'm just going to call this node A. Okay, so we have 4 nodes, so we have 4 unknowns already. Just like here we had 4 mesh currents, but then we introduced extra unknowns, like this one, right? So it kind of made the situation worse. And already I see that this is a supernode, right? Because we got 2 node voltages around this independent voltage source. And this is a supernode. We have these 2 node voltage around this voltage source. It's a dependent voltage source. Okay, so then we would just write the 2 KCL equations at these supernodes. So I can start doing that. Let's start with this one. So going here, VB over 100, and then now over here, VA over 250, and then going this way, plus 003 V delta. Where is V delta? It's right here. V delta is actually the same as node voltage VC. So can I just change that immediately? V delta is the same as node voltage VC. Okay, and then right here, that's going in, so minus 200 milliamps. Can I just write 0.2 amps? Okay, so that's for this supernode. How about this one? I'll start right here, so that's 0.2 amps, and then right here, VC over 500, over here, VD over 200, and then over here, going in, so minus 003 V delta, and again, V delta is the same as node voltage VC. Okay. We have 2 equations, 4 unknowns. So not great, but let's look at the constraint equations. See node A and B over here, which is more? This side, right? So VA minus VB is 20. Look at this. Which side is more? This side is more. VD minus VC is this, 0.4 VA. And VA is this node voltage. Okay, now look at this. 4 equations, 4 unknowns. And the equations are simpler than these 5 equations, 5 unknowns. Actually, it was more. It was 5, 6, 7 equations. But we kind of broke it down to 5. And already this looks simpler. For example, let's see, I'm going to move VB on this side of the equation. Okay, so right here, VA, we can substitute right there and right there. And then I can solve, see this VC, I'll move it on this side of the equation. Okay, and then V, let's see, Actually, let me do it the other way around. Maybe I'll solve for VC. No, maybe this way is easier. Okay. Doesn't matter actually. But then I can take this and just substitute it right there. So then this first equation will actually only have two unknowns, VB, VC. This equation will also have two unknowns, VB and VC. So now we're already down to two equations, two unknowns. I'll just write those out. Okay, so let me rewrite this equation here. Let me label them. Okay, so let me rewrite equation 1. So VB over 100 plus VA, which is 20 plus VB over 250 plus 0.003 VC minus 0.2 equals 0. Okay, and then equation 2.2 plus VC over 500 plus VD, which is this. VD is 0.4 VA plus VC. And what is VA? 20 plus VB. And we are here now. Now here minus 0.003 VC. Okay. Now, oh, actually, let me clear up my grammar here. From equation 1, and this is from equation 2. But now these two equations are just two unknowns. Let me clean it up one more step. Okay, so this first equation, let me just rewrite it. So for VB, we have 1 over 100 over here, and then 1 over 250. And that's it. So this VB, and then for VC, this 0.003. And then we have constants right here, 20 over 250, which I move it on that side becomes negative 20 over 250. And then this constant right here, if I move it on that side, becomes positive plus 0.2. Okay, next equation. For VB, I have VB is right here. So that's 1 over 200 times 0.4 VB. 0.4 over 200 VB. So I got this one over here. And then, is it anywhere else? Oh, that's it. Okay, so this VB. And then for VC, I got this 1 over 500 over here, which is 1 over 200. And then right here, minus 0.003. And we have constants. There's this one right here, which if I move to the other side becomes negative. And the last constant is right here. Right, so 20 over 200 times 0.4. So 20 over 200 times 0.4. So 0.04. Okay. Right, so already we have two equations, two unknowns. You can solve this by hand, right? Like you can solve this for V, write it in terms of VB, substitute it here, solve for VC. Or you can write it as a matrix, right? Just this goes here, this goes here, this goes here, this goes here, equals that goes here, and that goes here, right? And let the computer solve it for you. Okay, and then once you know these node voltages, then substitute it right here. VB goes here, then you have VA, VC goes here, and then we just solve for VA, then you have VD. Now you know all 4 node voltages. Once you know all 4 node voltages, that's pretty much it, right? We got everything. Let me look at the original question. Okay, so find the power absorbed by the source. So we actually need the current here, right here, this current for the source. Okay, so what we could do is we could write KCL for this node, KCL for node A. All right, so that would be IS minus 200 milliamps plus the current going this way, which is VA over 250. Okay, and then at this point we would know this node voltage. So then the source current would be 0.2 amps minus VA over 250. And then we have that current times 20 volts would be the power. Okay, so I hope that was helpful. Keep on practicing, and I'll see you in the next video.